Hello, this is Shula, and in today's video, we will learn how to assign oxidation states. So, in order to assign oxidation states, we have to follow the rules that are listed here on the right side. So, first of all, let's read the rules together, and once we read them and understand them a little bit, we will then learn how to apply them. So rule number one, the oxidation state of a free element is 0. So a free element is an element that's not charged and it's not bound to anything. Number two, the oxidation state of a monatomic ion is equal to its charge. So if you have just a single atom and it's charged, that's a monoatomic ion. The sum of the oxidation states of all atoms in a molecule is equal to the charge of the molecule. That's rule number 3, and that's the rule that we will use at the end when we're left with one atom that we haven't assigned oxidation state to. That's when we will invoke this rule. So I put a star next to it so that we remember that. Number 4, group 1A metals always have an oxidation state of +1. Group 2A metals always have an oxidation state of +2. And then fluorine has an oxidation state of -1. Hydrogen has an oxidation state of +1. Oxygen has an oxidation state of -2. And then it goes by groups. Group 7A has an oxidation state of -1. Group 6A has an oxidation state of -2. Group 5A has an oxidation state of -3. So now let's learn how to apply those rules. We will start with calcium fluoride. So this is a diatomic molecule and it consists of calcium and fluorine. So the way I assign oxidation states, I look at the rules and I pick the first rule that matches my molecule, right? So I have calcium and fluorine in my molecule, and I'm reading through the rules. Now, number 1, the oxidation state of a free element is 0. Is calcium fluoride a free element? No. Number 2, the oxidation state of a monoatomic ion is equal to its charge. We don't have a monoatomic ion here. Number 3, we skip for now. And then number 4, group 1A metals. Do we have a 1A metal? No. And then the next one, group 2A metals always have an oxidation state of +2. Well, that sounds right because calcium is a group 2A metal. So I will assign +2 to calcium. And now I'm left with just one atom. When you are left with just one atom, you have to invoke rule number 3, which states that the sum of the oxidation states of all atoms in a molecule is equal to the charge of the molecule. So our molecule is neutral. So that means that the sum of all the oxidation states has to be 0. So some oxidation state of fluorine will be multiplied by 2, and that will have to give us -2, right? Because +2 from calcium minus 2 is 0. So that means that oxidation state of fluorine has to be -1. So +2 for calcium and -1 for fluorine. It's extremely tempting to write -2 for fluorine, but you really should avoid doing that because we're concerned with the oxidation state per atom, right? So it's not for 2 fluorines, it's for 1 fluorine, right? So it's -1, it's not -2. And then the next one, we just have 1 atom of iron. So rule number 1, the oxidation state of a free element is 0. We have a free element, so the oxidation state is 0. Calcium 2+, we have a cation of calcium. Rule number 1 is about free element, right? It's not a free element. Rule number 2, the oxidation state of a monoatomic ion is equal to its charge. So we have to write 2 plus here, and that's the oxidation state. Carbon dioxide. Let's read through the rules. Again, I'm doing it in a very detailed way, but once you get used to it, once you get enough practice, it will be much easier to you, and you won't have to like literally read every single rule. That will be unnecessary. But for now, let's be thorough and we will understand what we're doing this way. So carbon dioxide, we have carbon and oxygen, right? So rule number 1, free element. We don't have a free element. Rule number 2, monatomic ion. We don't have a monatomic ion. We skip number 3 for now. Do we have group 1A metal or group 2A metal? We have carbon and oxygen, so no. Fluorine, we don't have fluorine. Hydrogen, we don't have hydrogen. Oxygen. Oxygen has an oxidation state of -2, right? So I found this first rule that matches my molecule here. So I will assign -2 to oxygen, but then I have to multiply it by 2 because we have 2 oxygens. Sorry, my screen just moved. And now I have -4 total coming from oxygen. And now that I'm left with just one atom, carbon, I have to invoke rule number 3, which states that the sum of the oxidation states of all atoms has to equal to the charge of the molecule. This is a neutral molecule, so carbon has to be +4, right? Because we have to balance it out with -4 coming from all the oxygens. If we had 2 carbons, right? Not to say that this molecule exists or something, right? But just let's say, right? If we had 2 carbons, then each of them would have oxidation state of -2, of +2, sorry, right? Of +2. So I'm just saying, you know, it's +4 because we have 1 carbon and then -2 for oxygen. So I'm putting my calculations in the red color, and then oxidation states are going to be in green color so that you don't get confused. Okay, so SO3, for SO3, we will also go through our rules, right? Number 1 doesn't fit, number 2 doesn't fit, number 3 we'll leave for now. Number 4, we don't have 1A or 2A metals here. Fluorine, no. Hydrogen, no. Oxygen, right? So again, oxygen is the first one that actually works here. So I will say -2 here, right? Plus times 3, I get -6. So I have -6 total for oxygen, like very similar situation to here. So because number 3, the sum of the oxidation states has to be equal to the charge of the molecule, the oxidation state of sulfur has to be +6. So +6 and -2. Now the next one, we have iron 2 chloride. Let's deal with that. Yes, so let's go through the rules. Number 1 doesn't work, not a free element, not a monatomic ion. Number 3 we'll leave out for now. Number 4, we don't have group 1A or 2A metals, right? So doesn't work. We don't have fluorine, we don't have hydrogen, we don't have oxygen. And then we get to rule number 8. Group 7A has an oxidation state of -1. And we know that chlorine is in group 7A. So we can assign -1 to chlorine. So we say -1 times 2 is -2. And then we have just 1 iron. So because we need to have total 0 by rule number 3, iron has to have an oxidation state of +2. And then we have something interesting. We have a similar molecule, but one that has one more chlorine, because iron is one of those atoms that is able to form different charges. Yeah, that's the right color. Yeah, so iron forms different charges. So here we have iron 3 chloride, and let's see how that affects oxidation state. So for the list of rules here, just like we did before, the first one that works is rule number 8. So we have -1 here times 3, have -3. So iron has to be +3. So +3 and -1. And then hydrochloric acid. Let's go through the rules. Number 1 doesn't work. Number 2 doesn't work. Number 3 we'll leave out. Number 4, we don't have any 1A or 2A metals. Fluorine, we don't have. Hydrogen. Hydrogen is the first one that matches here. So we say it's going to be +1 for hydrogen, and we don't even need to make any calculations. Again, by rule number 3, the sum of the oxidation states has to equal to the charge of the molecule. Molecule is neutral, so chlorine has to have an oxidation state of sorry, -1. Okay, this one could be a little bit more complicated, but we treat it very similarly to other molecules. Basically, we go through the list of rules and we only invoke rule number 3 when we are left with the last atom. Let's do that. We have 3 different atoms: potassium, manganese, and oxygen. So the oxidation state of a free element is 0, right? Not a free element, not a monatomic ion. Skip number 3 for now. Metals have positive oxidation states. Group 1A metals always have an oxidation state of +1. Great. So that means that we can assign +1 to potassium. And then we can just continue reading through the rules, right? Fluorine, we don't have fluorine. Hydrogen, we don't have hydrogen. We have oxygen. So we assigned -2 to oxygen, but we have to multiply it by 4. So we get total of -8 from oxygen, and we have +1 coming from potassium. So now we invoke rule number 3, which states that the sum of all the oxidation states has to equal to the charge of the molecule. Our molecule is neutral. So +1 minus 8, that's already -7. So to balance out -7, manganese has to be +7. And now let's just write that down. +1 +7 -2 makes sense, right? Because we have 2 metals here, and metals have positive oxidation states, right? Like the rules say. If you do those kinds of problems and you end up with metals having negative oxidation states, you did something wrong. Unless it's some weird exception I don't know about. Potassium chloride. So let's do this one. Let's go through the rules. It's not a free element. It's not a monatomic ion. And then number 3 we'll skip for now. And rule number 4 is the first rule that fits our situation. Group 1A metals always have an oxidation state of +1. So we say, okay, +1. And then by rule number 3, chlorine has to be -1. Manganese chloride. Let's see how manganese will behave differently once it's together with 2 chlorines and not in this more complex molecule. So we'll go through the rules, right? First three don't work. Metals, we don't have group 1A or group 2A metals. No fluorine, no hydrogen, no oxygen. Group 7A. Yeah, so that chlorine is group 7A, so we have to assign -1, and then we multiply by 2, we get -2, so manganese has to be +2. So this is a very good example, actually, because it just comes to show us that like you have some atoms that are not part of the rules here, right? Like a lot of transition metals are not really part of the rules here. And we have to deduce what they are based on rule number 3. So those atoms will be heavily affected by the atoms that they're bonded to, right? By the composition of the molecule. So when in this molecule, manganese has an oxidation state of +2, and in this one, it has an oxidation state of +7. So if you get results like that, like I've had students who got like they were doing problems like that, and there was a transition metal, and in one molecule, the oxidation state was like +2, and in another molecule, it was like +8. And the student thought that he did something wrong, and I'm telling him like, no, like this is normal. The oxidation state of those atoms varies very much. So don't be scared. Don't think that you did something wrong. And then finally, let's do water. So water, we go through the rules. Number 1, number 2, number 3 don't work. Number 4, no. Number 5, no. Hydrogen, right? That's the only one that works here. So +1 times 2, we get +2. And then oxygen has to be -2. So +1 and -2. So I think I mentioned that those rules are assigned like in order of priority. So rules on the top have priority over rules on the bottom, which means that if you are going to memorize those rules, you have to be very careful, and you cannot mix up the order. Like you have to memorize it in this particular order. Otherwise, you will do everything wrong. Like rule number 5, that fluorine has an oxidation state of -1, cannot be switched with number 4, right? Like it's very important that this order is very strictly followed. So that's what I wanted to go over. So I hope it was helpful. I'm going to post other content like that, like different topics in biology or chemistry. If you want me to make a video about any specific topic, please mention that in the comments below. And please give me a like and subscribe so that you don't miss any future content. And hopefully I'll see you in the next video. Bye bye.